want to do is we want to talk about what we just learned in our handout that we had before, which is this one right here, counting atoms, okay? So the first thing we want to do is we want to write something down. So the first thing about subscripts and coefficients. All right. So when we're talking about a subscript, we're talking about something that is attached, like HNO3. Okay. That was our problem number 2. First thing that you do is you write down what elements that you have. So you have hydrogen, nitrogen, and oxygen. When you have this subscript, it is only counting for the number is for the element that is attached. Which way do I need to go? I need to go over. Is that better? And down some. Is that better? Perfect. Okay. So if we're looking here, hydrogen's going to be 1, nitrogen's going to be 1, and then oxygen's going to be 3. 3, 4, and 5, which is a total of 5 elements. Okay. So that there is talking about a subscript. When we're talking about a coefficient, we're talking about a number that's in front. Say we have the same element, but this time we have this. We have a 2 that's in front. So we have a subscript and a coefficient, okay? So based on that, this gets distributed. So hydrogen, nitrogen, and oxygen. Hydrogen will now be 2. Nitrogen will be 2. And 3 times 2 is 6 for our oxygen, okay? That has to do with when we're talking about a coefficient. So those are the first 2 things we've covered. The next thing we want to talk about a chemical equation, okay? So H2O plus oxygen yields H2O2, okay? So that's just one I made up. So if we're looking, this yield means produces, or you can call it a yield. This is the reactant, and this here is the product. Okay? Based on the law of conservation of mass, it's going to tell us that the reactant is going to equal the product. It has to. Okay? So now what we're going to do is we're going to go to that sheet. So let's go ahead and go to that sheet. So we have synthesis, decomposition, single replacement, double displacement, and combustion are the 5 types of reactions. Okay? So for synthesis, you have A plus B equals AB. Okay? So when something is going through a synthesis reaction, what is happening is they're combining together to make a compound. Now, we kind of did that with our lab. With our lab, we were going through with our candy, right? And our water, and we stirred it, live heat or whatever, and it made a compound after it dissolved. So that's known as a synthesis reaction. A decomposition reaction is AB. So we have a compound. And this time, we're going to go and do the opposite of what we did with synthesis. So we're going to do A plus B. as you can tell, they're separated. So they were a compound, and then they actually went through a separation process. Everybody good so far? Okay. Now we have single displacement. So we have A, and we have our B, but now we have a C. So basically what this is, it's a compound adding something else to it. Okay? Now when we go through a single displacement, we still have our A, but our C comes over here and our B gets separated. All right? So that is single replacement. Double displacement, we have our A, we have our B, we have our C, but now we have our D. And so what they do is they switch partners. So I'm going to have my A, I'm going to have my D, and I'm going to add, whoops, D's a little bit different than that. Then we're going to have our C and our B. So with synthesis, we have two elements that produce a compound. On decomposition, we have a compound that produces two separate elements. When we have a single replacement, we have a compound and an element that produce where the compound switches partners. And when we have double displacement is where we have two compounds that switch partners. The only thing that's different between these two is it switches partners, and then, of course, you have one element by itself. So let's look at the practice on the right-hand side. So we have NaCl, okay? So what I'm going to do is I'm going to draw me a circle. I'm going to draw me a box. I'm going to draw me a triangle. And I'm going to draw me a diamond. Okay? So what we have here is we have A, B, plus C and D, right? Which produces a D plus C, B. So if I look at this and look over here, I know this is double displacement. Okay, so what I would like you to do is I would like you to try to do these other four. Now, I didn't tell you combustion, but combustion is where you're going to produce a gas. So let's see what you can do with the other four. Yes, ma'am. We did a lab report yesterday. That review. What we do in our lab, we do on Friday. We're gonna take care of when we put this out in the lab. Friday, get turned in. Friday. Okay, so we this is on. You can get findings from Friday. While y'all are working on that, I'm gonna go back and write some answers in for the first one, because I do have some people that wasn't able to do that. So I'm gonna leave you to do this while I do that, okay? So on this counting atoms one, what you're going to do is you're going to record every single element that you have. So you have Na, you have O, and you have an H. So what you're going to do is you're going to go through here and you're going to count how many elements of each one that you have. So there's nothing after it, so that's 1. Oxygen is 1, and hydrogen is 1. So if you add all 3 of them together, that's a total of 3. The next one is HNO3. You have a hydrogen, you have a nitrogen, and you have an oxygen. There's no numbers after any of those, so hydrogen will be 1, nitrogen will be 1, but oxygen will be 3. So 3, 4, and 5. Next one, you have Li and you have O. This one, you have a number that's attached to Li, so that would be 2. Oxygen, there's none, so that's 1, which is a total of 3. The next one is Li2SO4. So we have Li, there's 2 of them. Sulfur, we have 1. Oxygen, you have 4. 4, 5, 6, 7 is my total. NH4Cl. So you have nitrogen, hydrogen, and chlorine. Nitrogen is 1. Hydrogen is 4. Chlorine is 1. 4, 5, and 6. Next one, Ca, Cl, and O. Ca is 1. Cl is 1. And oxygen is 3. 3, 4, and 5. H2COCH. So I have a hydrogen, I have a carbon, and I have an oxygen. There's 2 hydrogens here and 2 there, which would make it 4. 1 there, which would make it 2. And 1 there, which would make it 1. 4, 5, 6, 7. Total of 7. Mg, oxygen and hydrogen. But this time I have a bracket around OH, so that gets distributed. So my Mg is 1. Oxygen, I'll have 2. Hydrogens, I will have 2. So 2 plus 2 plus 1 is a total of 5. Al, O, and H. Al is outside of the bracket, so that would be 1. Oxygen is inside the bracket, so that's a 3. And my hydrogen is inside the bracket, which is 3. So that's 3, 6, and total of 7. Those are fairly easy, but then when you get down to the bottom, that's when they start getting harder. So we have nitrogen, hydrogen, carbon, nitrogen, hydrogen, carbon, and oxygen. Those are all the separate elements that we have. I only have 1 nitrogen. Hydrogen, I have 4 plus 3, which would be 7. Carbon, I have 2. And oxygen, I have 2. 7, 8, 9, 10, 11, 12. Sodium, carbon, hydrogen, and oxygen. Sodium, I have 1. Carbon, I have 2. Hydrogen, I have 3. And oxygen, I have 2. That's 3, 4, 5, 6, 7, 8 total. Next one, nitrogen, hydrogen, phosphorus, and oxygen. But here we have a number outside of the bracket, so we have to distribute that. So my nitrogen just has 1 times 3, which is 3. My hydrogen has 4 times 3. That's 12. Phosphorus only has 1. And oxygen has the 4. So 12, 13, 14, 15, 16, 17, 18, 19, and 20 is my total. The last 3. I have Ca, I have P, and I have O. Ca, I have 3. P, I have 1 times 2, which is 2. And then 4 times 2, which is 8. 8, 9, 10, 11, 12, 13 is my total. Fe, C, and O. Fe, there is 2. Carbon, there is 3. And 3 times 3 is 9. 9, 10, 11, 14. And then the last one, Al, S, and O. Al, there's 2. Sulfur, I have 3. And oxygen, I have 9. 9, 10, 11, 12, 13, 14 is my total. So that is the first page. Now what I'm going to do is I'm going to join y'all with the other practice ones that I asked you to do. Okay? So if we look, we have 2H2 plus O2 yields 2H2O, right? So we have an A plus a B yielding an AB. If I do, and I look back up here, it tells me this one is synthesis. The next one, I have A plus B and C, right, guys? So that is A, C plus B. Well, there we are. Single replacement. CH, so we have C and H plus we have an oxygen, right, which is a C. But this time we have C, and C, and then hydrogen, which is a water, B and a C. So can I tell you, is that double displacement? Double displacement. And then the last one, KClO equals KCl plus O, and this one is combustion. Everybody good? Flip your paper over. What do you see over here? Well, the answers. Let's go to the next page. Understand the parts of a chemical equation. Okay? So here it says that we have a chemical equation is where you have a reactant and a product, right? Subscripts and coefficients. So if I'm going to use that, I can go through, and it's giving me, and it's going through the example here of CO2 plus 6H2O yields C6H12O6 plus 6O2. So the first thing we're going to do is we're just going to go and use this equation here, and we're going to use that for everything up here. So if we're talking about a reactant, we're talking about the 6CO2 plus 6H2O. That's my reactant. My product is C6H12O6 plus 6O2. In here, I have subscripts and I have coefficients. So for my subscript, I'm going to use O2 because that one is that. If I'm doing a coefficient, I'm going to do 6O. That is an example of just this one right here to show me that I understand which one is a subscript and which one is the coefficient. Now what I'm going to do is I'm going to count how many carbons I have. So this tells me I have 6 carbons. My hydrogens, I have 6 times 2, which is 12. My oxygens, 6 times 2, which is 12, plus 1. Now I'm going to go to the right-hand side. Carbon, I have 6. Hydrogen, I have 12. Oxygen, I have 6. 6 times 2 is 12 plus 6, right? That's 18. Is this a balanced equation? No, it is not. The reason why it's not balanced is the carbons are fine, the hydrogens are fine, but the oxygens are not. Right, guys? So let's go back and check and see about the first one first. So I agree that carbon is 6 here. I agree that hydrogen is 12, but I'm going to check my oxygen count. Okay? So 6 times 2 is 12. Oh no, I made a mistake already, haven't I? Plus 6. If I did that, what do I get? 18. I'm so glad I went back and checked to make sure. Now, is this a balanced equation? Yes, it is. How do I know it's a balanced equation? Because both have 6 carbons, both have 12 hydrogens, both have 18 oxygens. So it says, why did the reactant and the products have to balance? And that is because of, based on the law of, what did I call it before? Law of what? Conservation of matter and mass. Now it's asking you for a review of what the 5 types of reactions are. Well, I have synthesis, decomposition, single and double displacement, and I have combustion. I can't spell. E-U-S. Everybody good so far? Look on the back. Nothing. We have one more paper to go. We're going to save that for tomorrow. So what I would like you to do is I would like you to take all these pictures of all these things that we've done today, and I want you to put it on